Hello everyone, welcome to Mayur Programming Club. Today we will be solving another daily Leetcode problem, and the problem's name is word search. So you will be given a grid of m cross n size, which will be consisting of characters, and you will be given another thing which will be a word. Okay, and you have to return true if that word exists in the grid. Okay, and there is a extension of the problem, or there is further to the problem that the word can be constructed from the letters of sequentially adjacent cells. Okay, where the adjacent cells are horizontally or vertically neighboring. Okay, so the same letter cell may not be used more than once. Okay, so this for example, if you take this particular image, let's open the board. Okay, let's say this is the board that will be given to you. Okay, and let's say the word to that you have to find out whether this word is existing in this board or not is A B C C E D. So A B C C and then E and D. Okay, so the cells that you can use should be sequentially adjacent, and adjacency is valid in 4 directions. So let's say this is the cell which you are at currently. Okay, this cell, so you can move in either of these directions. Okay, so if you are at F, then you can move in this direction, this direction, this direction, and this direction. Okay, left, right, up and down. Okay, horizontally and vertically. So this is what this statement means, and the constraint is very this constraint is very crucial to be noted, because you cannot use one cell more than once. For example, if you take this particular matrix as your example, and let's see what is the word that is to be checked. A B C B. So A B C B. So you can see that this word although can be formed like this: B A B, then C. Okay, and then again you can go to B, but this revisiting of same word or use of word more than once is not allowed. Okay, that's why this word will not exist. Otherwise, if this revisiting would have been allowed, then we would have returned true from here. And this is the sole reason that we are returning false from here. Okay, and yeah, so this condition should be kept in mind, that the same data cell may not be used more than once. Okay, and let's have a look at the constraints before discussing the approach. M cross n will be the dimensions of board, and m and n will be of order 6, and length of the word will be of order 15. And it is mentioned that board and word consist of only lower and upper case English letters. Okay, and there is a for verb also. that could you use search pruning to make your solution faster with larger board? Okay, what does it mean by search pruning is, we will although let's say you are at this particular at a certain point in your search, you are at this cell, so you can essentially go in 4 directions from this cell. Okay, but you will not be visiting those branches which are not leading to your solution. You will prune those branches without visiting them. How you can do so, I will tell you in the approach. Okay, it will be clear to you how the pruning is working here. We will be discussing the pruning solution itself. And now without further delay, let's move towards the approach. So let's take one of these examples. I think this should be fine. Let me erase some unnecessary part. Okay, so it is fine. Now let's continue. So what we will be doing is, we will be firstly starting with the cell which is equal to the first character of this word. Okay, if we mark the indices of this particular word, then we will be traversing this word from left to right direction, one character at a time. Okay, and firstly we will be seeing which of the characters in this entire board is matching the first character. So you will be able to see that there are 2 cells or characters that are matching the first character of the word. Okay, so you will be starting your search from there, starting one by one. So since we will be traversing this whole matrix in this particular fashion, first we will traverse the first row, then second row, and then the third row. So this top A will be the first one to be visited, so this branch will be explored first. Okay, now when we will be at A, we will be essentially having 4 directions to move. Okay, these 4 directions, although some of the directions like this one and this one may result in you moving out of the boundaries of the board, so we will not be doing that, but we will be proceeding with the options that are inside the boundaries. And this is where pruning comes. We will only be exploring those branches whose next character is matching with the next character of this string. So next character of this string is B, and which of these two among this one and this one is matching with B. So this is not matching with B, so we will prune it. So here the pruning comes. Okay, prune this branch and no further exploration. Okay, so we will be only visiting this one. Okay, so we will be going from A to B. So now we are at B. These 2 letters have already been matched. Now we have to check for C. Okay, so when we will be at B again, we will be having 4 choices. And one thing that I would like to mention is, we will somehow keep track of already visited nodes on a particular branch. So although B can visit this A again, but we will stop it from doing so with the help of backtracking. Okay, so backtracking, or you can, what we will do, when we have visited a certain cell while exploration, we will temporarily mark this as star. Okay, so this is star. Okay, so because of the pruning, star will not match with any of these characters because only upper and lower English case letters are allowed here. So we will not be visiting this A again, and we will essentially be having only two choices, either to move to C, and you can also move to F. Okay, and this one will result in out of the bound, out of the boundaries of this box, so we will not be considering it. Now again pruning comes into picture. This particular branch is not contributing since the very next character is C and this one is F, so we will prune this. Okay, so same thing is being done here, and so we will be proceeding with C. Okay, so and similarly the whole thing goes on, and as soon as you have exhausted all the indices in this particular string, I mean your index that you are visiting is equal to length of this particular word. Okay, word dot length if you are implementing in Java, then you will be returning true, saying that okay, we have matched all the characters and this word is found in the this particular board. Okay, and this is whole thing will be working out. Let's see the implementation and let's see how this thing can be done programmatically. Okay, so it will involve backtracking. Okay, how backtracking? Because if let's say at a certain point you are not able to reach your destination, then you will backtrack. Okay, and try different path. And pruning also is used. Pruning I have shown you. Okay, this is pruning into picture. So let's see the solution or the implementation, you can say. Things will be more clear here, or if you want I can take this one to board also. Let's take it to the board. Okay, so let's remove this toolbar. Okay, so let's discuss how things are going in this particular code. So what we are doing here is, firstly we are matching the very first character of the string. Okay, so searching for only those branches whose first character is matching with the first character of the word. Okay, so this is the first character of the word, and if your cell is having a character that is matching the first character of the word, then only we will start exploration from that cell. Okay, and if let's say your word is something like A only, and you are having a box or this board and it is having many A's, so you can return true with any one of these, since the word is of length 1. So if that's the case, then you can return true, and if that's not the case, then you should be trying to do this depth first search. This is essentially depth first search, and those of you who are new to this DFS, I will try to provide a link of an article describing what depth first search is. Okay, as the name suggests, you first of all go to a certain branch till the very end and then come back and then explore some other branch. Okay, so this is what depth first search is essentially. Anyways, I will be providing the link. Now moving further, now coming to the solution below, this is nothing but the 4 directions that we are allowed to move. Let's say you are at this particular cell, so you are allowed to move in these 4 directions. Okay, so this particular one, if you consider it, it is let's say this one is at 0 0, so this is nothing but 1 above it. So what it will be, it will be 0 minus 1. Okay, and this particular one is 0 plus 1. Okay, and this one is you must have guessed 1 0, and this one is minus 1 0. Okay, so these are the 4 directions in which you can move with one cell. So then coming to this particular DFS function, it is involving backtracking also. So if you know, this is the base case, if you have matched all the characters of the string, then your index must be equal to the size of the string. Okay, in this case you have matched all the characters, all characters of word. Okay, then you will be returning true. Okay, and yeah, then what we are doing here is the backtracking part coming into picture, and here we are essentially avoiding revisiting the same cell. We are temporarily marking the current cell with star. Any character will do that is not in the range of the characters that is allowed for board. So since we were mentioned that only upper and lower English letters are allowed, so I took star to mark it temporarily visited. Okay, so we are marking it visited, marking this current cell visited. Okay, then we will be exploring the 4 directions from which we can move to the next cell from the current cell. So we should be checking whether these coordinates that we are generating with these 4 directions are within the board or not. Okay, if the coordinates are within the board, if coordinates are within board, then you will proceed further, and if either the very next index is equal to the size, it means that you have matched all the characters. If that's the case, then you will proceed further, or if the next character is matching the the next cell's character is matching the next character in the word. So this is where the pruning part is coming into picture. This pruning is being done here. Okay, so if this condition holds true, this is pruning. Okay, only visiting those branches which are potential branches that will contain our answer, or which will lead to the word being found. Okay, so if it is a potential branch which can lead to the exploration of the whole word, then we will explore it. And if the whole thing is returning true, then you will return true from here itself, and will not explore other directions. There is no use of that. And once you are done with it, you will simply mark this current cell as unvisited. Mark current cell unvisited. Okay, and if you were not able to find the word anywhere in this particular board, then you will be returning false in that case. And this last function is just a simple function to check whether your new coordinates are within the boundaries of the board. Okay, so the new coordinate R and C, row and column, should be at least greater than -1 both, and R should be less than the number of rows in the board, and C should be less than the number of columns in the board. Okay, since it is a zero based indexing, that's why. So this is the whole approach, and how we will be solving this particular thing, this problem. And yeah, that's pretty much it. And other than that, if you are still having any doubts or any queries in general, then you may ask them in the comment section. And for the time complexity part, although theoretically speaking, since the word length was 15, so with each index you are having 4 directions to go. So theoretically it would have been upper bound, if we are taking, then it would have been 4 raised to power 15 something. Okay, but that will not happen for sure, because of this pruning, and out of, sometimes it will be out of the boundaries of the board, so it is loose upper bound, you can say. Okay, although it will be significantly lesser than this. And as far as the space complexity is concerned, space complexity wise, what you are using here, I mean, this is just 2 into 4 size array. Okay, and this whole DFS thing will be using a recursion stack, and that recursion stack will be having size equal to the maximum depth of the branch, of a branch possible. Okay, so that will be the time complexity because of recursion stack, and this will be the time complexity overall. So that's pretty much it for the time complexity and space complexity analysis. And then I would again say that if you are still not able to understand or having any kind of doubts, then you may use the comment section. So thank you for watching. Have a great day ahead.